do that. Chain rule, exponential, and log. Now before we do, copy those down. Most of it you already know. The ones you don't know, this is your power rule. Doesn't matter if it's in brackets, it's still the same thing. That's a chain rule problem. Derive the inside and you get A. So derive AX plus B, you get A. Drop down the power, so you get N minus 1. Okay, it's the same thing. Drop down the power, that's why you got A times N, and then this minus 1. So it's the same thing. So if you ignore this line and you get that, that's all you need. You don't need the second line. That's just, it only works for linear equations. If I put x squared there, the whole thing's wrong. Yeah? So I'm just saying, you don't need to know this one. If you're wondering how they got it, same thing again. This is ax plus b to the power of n. Find the derivative using power rule, drop the n down. So dy dx, drop the n down, so you get n times. Now, you have to do the chain rule, derive the inside. So derivative of ax plus b is a, which is why you do times a, and it's ax plus b to the power of n minus 1. Okay? That's really just a chain rule. That's just a chain rule, what they've done there. Yeah? So I'm just saying you don't need to memorize that rule. A lot of students will try to memorize that. You don't need to. Yeah? If I rearrange the order, it might make more sense to you. Drop down the power times ax plus b to the power of n minus 1. Yeah, that's how you would normally do it. But using chain rule, you also know we have to derive the inside. So derivative of ax plus b is a. So you have to times that by a as well. Yeah? So this is really your dy du times du dx. Okay, that's where the rule comes from. Yeah? But at the end of the day, you don't need that, because if you know how to do chain rule, then all you needed was a power rule. Power rule, chain rule. Yeah? Anyways, that's your power rule there. Next ones that we're learning is now 9G and H. This is G. This is H. I personally don't like the A there. Then you have to follow this rule. But just for now, you can copy that, and I'll work you through knowing how to find the derivatives. Yeah, but for now, this is your rule for 9G. This is your rule for 9H. And then you go to 9I, you'll be doing sine, cos, tan, circular function. So that's 9I. 9J is product rule. Yeah? So there you go. That's your 9I. There's the rule. So I'm going to just get you to copy them down. But then in the next session, I will cover I and J all together. So you can do chain rule, product rule. Yeah, because at the end of the year, it's likely to be one of those functions there. It's going to be either log of a sine. Maybe it's an exponential of a quadratic. Okay, you have to be able to do chain rule or product rule. So examples would be something like this. They might give you y equals e to the power of 2x times sine of x squared. And they say find the derivative. Okay, but if it's the first question of exam 1, it's likely they won't even give you their x squared, and they'll just say that. And they'll say find the derivative of that. Okay, that is not a chain rule, that's a product rule problem. And every year, you get a bunch of kids who can't do that. It's the difference between knowing when it's a chain rule and when it's not. So if you want to make that a chain rule, this will be a chain rule. There you go. That's a chain rule problem. Okay? But anyways, here we go. Let me know if you need some more time to copy all the formulas. Derivative A cos is negative sine, derivative sine, positive cos. Derivative of log, 1 on x. Derivative e to the power of something is the same as itself. Derivative tan, which is the one that Naz, he's not in this class. So we'll find out next session. That's the rule that you need for tan. Which I'm not sure, I'm pretty sure you learnt it last year. Hands up if you learnt that one last year. Derivative tan.
No, we didn't.
No, we didn't?
We just did it.
It's alright, well, that might be a new one then. Okay. Alright, next slide. Chain rule, product rule 9J, quotient rule 9K. Yeah? Don't write this one down, ignore it. Chain rule is just to remind you that it was from it's meant to be 9E actually. 9E. But I'll show you my formulas and I want you to memorize it my way. Yeah, so that you'll know. So don't copy that down unless it's chain rule. Right? Forget about 9J. I'm just giving you an outline of how we're gonna sweep down this week with a few slides. Yeah, 2 slides and 5 or 6 exercises. Yeah? All right, let's go do some problems now. Let's practice. Here we go. How does it all work? Remember I said it's all about learning to use a chain rule. You get a rule, and the question is, when it's different to that, when you can't use the rule, chain rule's there to make it easier. So the rule that we know so far is when we have y equals to e to the power of x, then the derivative is equal to e to the x. It's itself. That's all we know so far. Anything that's different from that, we don't know. Anything that's different from that, we have no idea. That's why we're going to use chain rule. Okay? So in this case here, if I have a look at this problem, e to the 3x, that's something I don't know. If it was e to the x, I know. But it's e to the 3x, I have no idea. So therefore, I'm now going to use chain rule. So the rule that you guys copied in the second slide, I know it has an a there, and I don't like that a because it changes your perspective of when chain rule comes in. Yeah. The rule I like is the one without the a, and that way you can sort of see how chain rule comes about. This is how chain rule comes about. They're like, all right, e to 3x, I have no idea. So chain rule says make up a variable to make it easier. So how do I make it easier? I'll say, all right, well, that's an issue there. Instead of having 3x, I say, what if I let u equal to 3x? Why do I do that? Because that now changes my problem. Instead of y equals to e to the 3x, it is now y equals e to the u. See what I'm doing? I'm just saying, instead of having 3x, what if I replace that with one variable? Why did I do that? Because now that doesn't look different to this. So if I say find the derivative dy with respect to du, because there's u terms there, dy du should equal to, according to the rule, derivative e to one variable. So e to the one variable is itself. So I can say, all right, dy du must be e to the u. Just like what you did in exercise 9E, chain rule, if you derive with respect to u, then you have to also now derive with u with respect to x. So here we go. We know that this is u equals to 3x, so du dx, what's the derivative of 3x? What does that equal to? 3. Okay, so we know it's 3, and according to chain rule, we say dy dx must equal to dy du times du dx. In our case, that would mean it's e to the u times 3. That's why the answer is 3e to the u, which is the same thing as saying 3e and whatever u was, and that's your rule. So that's your rule from the 2 slides before. Remember how they had a? They had y equals e to the ax, and I told you guys to copy it, and you wrote down dy dx is equal to a e to the ax. And the reason why I don't like that is because it takes away the idea that you actually, the reason why there's an a at the front is because you found the derivative of ax. Yeah? That's how you got the 3. That's why the 3's there. Because you found the derivative of 3x. Gives you 3, that's why you know it's 3. Why do I emphasize that? Because in your exams, they know that you don't know that. Well, a lot of you don't know that. And so what they do is this is what they do in the exam. That's the only difference. You can easily get that kind of question in your exam. It'll be e to the power 3x squared, and kids will do the same things. They'll do the same thing. They'll remember, oh, but I remember this rule here. So you know what? I'm just going to put a 3 here. I'll put a 3 e to the 3x squared. And they're almost there. The only thing they're missing is obviously it's not 3. What should it be? 6x. Because you're finding the derivative of 3x squared, not 3x. And that's the difference between, that's how you know if a student gets it or they don't. Okay, so you only get a rule and you use chain rule. Anything different from that, use chain rule. So all of these ones here are all different to what you know. It's negative 2x. Same thing, replace with a u, find the derivative. Replace that with a u, find the derivative. We'll bring that up and replace with a u, find the derivative. Okay, so I'm going to do all 3, and I want you to see that layout. I'm doing the same thing. I'm just replacing it all with a u so I can find the derivative of an exponential. Same rule. One rule, just over there, and I'm going to use chain rule to make it easier for myself. Okay, so let's have a look at b. I'm going to do b again. So same thing. If I have y equals e negative 2x, I'm going to say let replace this with a u. So I said let u equal to negative 2x. How does that change things? That now makes me, or gives me, y equals e instead of negative 2x, I have e to u. We know that dy du is just itself. Using chain rule, that means you have to find the derivative of u, so it's du dx over here, and that gives me negative 2. Using chain rule, put them both together, so now dy dx has to equal to dy du multiplied to du dx, and we know that answer is now e to the u times negative 2, and your answer is negative 2e, negative 2x. Now, by the end of the year, or the end of this chapter, you are not required to do this. All these techniques here, I'm just showing you how it's done and how it works to remind you of what we did last year as a chain rule and what we're doing this year to find the derivative of an exponential. Okay? But what you're required to at the end of year is that, yes, you should be able to look at that and tell me the answer is negative 2e to negative 2x. Find the derivative of this, bring it down. Find the derivative of this, bring it down. Okay, so I know by looking at that next one, I know the answer has to be derivative of 2x plus 1 is 2, e to the 2x plus 1. That's one you're meant to be able to do by end of year. Yeah? Same thing with this one. I'll look at this and I'll say, that's like saying e to the negative 2x plus e to the 3x. Therefore, derivative is equal to negative 2e negative 2x plus 3e to the 3x. Don't leave your answers with a power. That's a negative, so you write out negative 2e 2x plus 3e 3x. That's what you're required to be able to do by end of year. Okay, well technically by the end of this chapter. That's what I want you to be able to do in terms of speed. In terms of practicing, that's what I want to see you do. Okay, write out du dx, dy du. Yeah? Now, just in case you were confused about what I just did, I'm just going to do C and D in the long way. Okay, so here we go. We've got y equals to e to the 2x plus 1. What's the issue? Replace that power because that's what we don't know. That's what we don't like. So I'm going to write, okay, let's replace that with a u. U equals 2x plus 1. How does it change my problem? I now have y is equal to e instead of 2x plus 1. I now have u. So using chain rule, dy du. We know that dy du is just itself. Du dx equals 2. Put them both together. Dy dx multiply to each other eu times 2. That's how I got e to the power of u, which is 2x plus 1. And that's what I got over here. Okay? That's the technique. And it's the same for third one. I brought the power up and do the same thing individually. How do we feel? Is that easy? Good? Your turn. Yeah, that one. Have a go at this question. Remember, at the end of the day, don't forget, all these techniques I'm teaching you, remember, it goes back to what is the purpose of finding the derivative? It is to find the gradient of what? At one point, the gradient of a tangent line. Always a tangent line. Yeah, it's a straight line, tangent line at one point. Don't forget that. All these techniques you learn is to help you find the gradient of a tangent line at one point. And in this case, they already told you what the point is. And they said it's at 0, 1. So you know at x equals 0, you've got a tangent line to that point. What is the gradient? That's what the question's asking. Find the gradient of the tangent to the curve at. So the first thing you need to find is the derivative, because the derivative gives you the gradient. The gradient at what point? At 0, 1. So try the first one for me. 4a. So that's all you're doing. 9G, 9H, 9I, all the same thing. Finding the gradient, finding the y-intercept. Find the coordinates. Maybe you have angles. Tan of theta equals gradient. Tan of theta equals gradient. I'm just saying that's what they'll do for every exercise. They'll go through, find the gradient, find the coordinates, find the tangent line, find the gradient if you have an angle.
我怎么这么奇怪？哦，不应该解开。这是1等于0，1等于0吗？1等于1，
还有啊，上面写的大 x 等于0啊。
哦。
这张这么短的吗？
Oh yeah?
Are still recording?
Yep.
Sure. 2x 加3 2x 加3x 加上2，把 gradient 的0把x 等于0前面一项取消了，后面一项等于2，所以说在 a 的题答案是2，然后1是4加2，1的时候没必要
做 S 一样啊，你这 A 都抽出来了 ，B 都可以投啊，你同一个一个了，带个预算的，
算你个头，1道题
算我不了的呀。
还算，你的大脑很难计算。2x 加3加2，这个有没有这么难？这题好难。然后说很对。2x 加3，2x 加3，4加2。
这个2是一直的，
我是错了。2x 加3不是1吗？
呀，1上面是 f2的，右边这边2是2的。
对，2x 加3，1的话2x 加2，2加3，5倍的1多少？4，1的话是4，
对，5倍的。5倍的垃圾，操！妈，你个菜鸡，天天手工垃圾，然后好意思讲。说你从一得那个谁下面就看。
怎么说还没有
Check your answers. And have you got them correct? There are 3 parts to it. First step is getting the correct derivative. So you know that deriving 2x is 2. The problem is here. That's 9g. Find the derivative of this. X squared plus 3x is the issue. So let u x squared plus 3x to u dx. E to u. Derivative of x squared plus 3x is 2x plus 3. Put them together. That's your derivative. That tells you the gradient. At x equals 0. At x equals 1. Sum into your gradient formula. That's how I get it. Okay, so if you found that tricky, again, work on the exercise to get your head around finding the derivative of e to the x squared plus 3x without doing what I just showed you here. Okay, eventually I want you to be able to look at it and tell me what the derivative is. I don't want you to do that, let u equal to this, du dx, dy dx. It takes a lot of effort. Yeah? How do we feel about that? Was that okay? Yeah? Then let's go back to now exercise 9H. Okay? Let's have a look at 9H. I'll go back to that slide after I teach this one. All right, 9H. 9H, you had this rule. This is what your rule was. Y equals 2 log e of x. So it has to be log base e of x. Then dy dx was equal to 1 over x. Okay? So again, same thing. For exercise 9H, is going through the same thing. You're using chain rule to make your problem easier. So right now, if you have a look at it, I have log e of x squared plus 2. That's a problem. That's not what I'm used to. I'm used to log e of x, not log e of x squared plus 2. So because this is the issue, I'm going to say now let u equal to x squared plus 2. Why do I do that? Because now that changes the problem to y equals log e of u. That's why. Okay, so if I replace the x squared plus 2 with another letter or another variable, that now is easier because that looks exactly the same as log e of x. It's just a different letter. So if I ask you to find the derivative dy du, then you know it has to be 1 on u. Okay, that's what we like. But because we made up another variable, now we have to find the derivative of du dx as well. What's the change in u with respect to x? In our case, derivative x squared plus 2, which is? 2x. I don't know where you got 84 from. Okay. And so, now dy dx is equal to the multiplication of the 2, so it'll be 1 on u multiplied to 2x, which gives you 2x over whatever u was, which was 2x squared plus 2. Okay, and that's my derivative. Right, so it's the same thing as your exponential, you're just using a different rule. And now you can use that concept for sine, cos, and tan. Okay, if you understand what I'm teaching you there, then you can use chain rule for exercise 9i. Yeah, 9i is the same thing. You're going to find the gradient, you're going to find the coordinates, and maybe a possible tangent line, yeah? But it's the same drill over and over. Every exercise is doing the same thing. You're just trying to find the gradient of a tangent line with different types of functions. In the case that I just taught you, you just learned how to do exponentials and logs, yeah? How would we do the next one though? This one's tricky because it's log e x all squared and we want to find the derivative. So be careful, I'm going to write it out properly. It is y equals bracket log e of x all squared. Be careful with this one. What would you do? It's not log e of x squared, it's log e the entire thing all squared. How do we do this? Fantastic. Sorry, what was your name? Lawson. Lawson. So we're going to let u equal to. Now, what I want you to see is, remember, you're using chain rule to make your problem easier. The outside function tells you what you should be having. And if you have a look at that, it's meant to be something down to. This is a power rule problem. If I didn't have log e of x, it would have been a power rule. If I gave you x squared, and I said derivative of x squared, you would have been 2x. In our case now, the problem is the log e of x, so that's why you let that for u. So you can derive that. It's u squared. You can all do that. That's the issue. Yeah? So now because I let that equal to u, I get a new equation. I get y is equal to u all squared. And that's nice because we know the derivative dy du has to equal to u. But because you let u equal to log e of x, now you have to find the derivative, which is du dx. What's the derivative of log e of x? 1 on x, which is what we already know. It's up here. Okay, so now putting them both together, dy dx has to equal to 2u multiplied to 1 on x. And that gives me now 2 times log e of x, because that's what u is, times 1 on x. Okay? Simplify it down just to write as 2 log e of x over x. And that's a good answer there, dy dx. Perfect. Was that easy? Yeah? Okay, and that's exercise 9H. The only difference is they'll ask you to find the gradient. In a couple of questions there, they'll say find the gradient at this point, at that point, find the coordinates, so you got to work backwards. Yeah? Yep, that's why. Because if you sketch the graph of the log can't have log of 0. an asymptote, a vertical asymptote. And that also now applies to the derivative as well. You can't have the derivative of 0. So that's really good because that's what you're required to know. Sometimes in these types of exams, they won't give you that. But then they'll have the question, they'll say, what's the maximal domain? And you're meant to be able to look at this and use composite functions. Everything you learned in chapter 1, without me giving this to you, you should be able to predict what that graph should look like. Anyone know? This graph should look like yeah, actually, you did do that right, actually. And as you just said, if you picture it, log e of x looks like this. But now you think about it, what you're actually doing is saying, take that squared. So if you square it, it means all the negative y values will now go up. And so you should have something like that, but it will be larger. Okay, because all the negative values become squared. So you think about it, where all the y values are down here, all those are your negative y values, they become squared. So if you square them, all the negatives become positive, but they get steeper because you're squaring them. So if this y value at x equals, let's say, half, at that point, let's say that was 10, negative 10. The negative 10 squared now skyrockets it up to positive 100. So that's what happens when you square them. But the asymptote obviously still stays there. It's still there. You haven't changed the asymptote. That's why x has to be greater than 0. But if you were to ask your range in that case now, you should be able to say it has to be from 0 to infinity, the range. It's different from just your log graph. Okay? But the skill that I just showed you there, whatever I'm saying with you, you're meant to be able to do. It's the analytical skills that in chapter 1, you're meant to be able to look at the domain, properties of log, properties of an x squared, odd and even functions. How does that change things? That's your job. Yeah, and that's where it gets difficult because I can't teach that for you. You have to learn to look at it yourself. You have to make a judgment call of what it means. Because your functions will change. I can never predict what the examiners are going to put as the functions, but they will use all the functions you've learned from year 11 to now. It's the same properties, you just gotta learn to analyze them. Yeah? So I can easily change that to log e of x squared plus 1 all to the power of negative 2. And then you still have to look at that and analyze it. Well, if it's negative 2, it's a fraction, that means there has to be a horizontal and vertical asymptote. And how does a log do it as well? How does it change? What can you have? That's what you're meant to be able to do. Okay, so that's the skill from chapter 1 that you want to take out. Okay? That's what I meant. Chapter 1, functions and graphs, calculus, it's 3/4 of your course. All of that, if you think about it, there's only 4 areas of study. Functions and graphs, calculus, algebra, that all comes in one. And you've got probability. Probability is really easy. Yeah, at the end of the year, I can teach you in 2.5 weeks. You'll be able to sort of understand what you need to do in exam questions. Yeah, but the hardest one, 3/4, is all of this. Learn your functions, learn your properties, learn your set notations, learn how to write it properly, visualize the graphs, answer it appropriately. That is the hard part. Other than that, everything else is easy. Yeah? All right, how do we feel? Pretty good? Can I move on? I'll move on. For those who didn't copy all of this, it's back there again. You want to have a look? All good? Okay. And these are the answers. And 9G, you can do that if you want. Actually, am I doing the answers there? Where's the 9H? All right, there we go. Try this one. Do I have an exam question? Hold on a second. What is that? You little kids. All right, here we go. You can see it again. I like it too, actually. Yeah. That's my palm.
What is that? Oh, you scrunches.
Whoa, wait, do it again.
You know, this is getting recorded. These are my year 12s, by the way.
Is there a sound cue?
There used to be. I used to go on and I find a scrunch sound. And yeah, it's pretty cool. Where's the question? Because my year 12s in EBIS that time didn't learn anything.
Yeah, well, we're not year 12s or in EBIS, so.
As in learn anything is that in the class, all they were excited about is the next slide. Go to the next slide. I'm like, okay, boom, and then they zone out. So I learnt to keep your attention. Don't make it like a circus. One of the things I think I learnt part of teaching this, say you want to educate, not entertain. And I think that there's a fine line between that. entertaining students to keep them engaged. But if you entertain them too much, they come in for the show, not to learn. And it's like, find that balance between the two. Yeah. Educate, not entertain. Try this question. Question 5 of exercise 9H. Same thing, find the derivative. What does f-1 mean? In the exams, most students forget to read the question. So read the question and it says f-1, find it. A lot of students don't find it. And they lose a mark for something they know. It's ridiculous. Just out of curiosity, anyone know what this is saying here? What are they telling you to find? d/dx just means the derivative of your function with respect to x. Okay? So really they're just saying find the derivative of this. It's tricky. In the exams you are required to know how to do this one. Log e of f of x. Most students don't know how to do that. They're so used to seeing like a function in there. When I use f of x, they can't do it. Okay, so it's all about your set notations again, learning to write it appropriately. So question 8 is a nice one. Reading the questions, given that f of 0 equals 2, knowing what that actually means.
这个要怎么变？哦啊？哦，哎啊？哦。那这个也要，就又要跟你提到。好难啊！我操。
Problem 5 is a typical, not typical, but it's what we call the double chain rule. So you do chain rule twice to get the answer. That's what it is. Ask Mr. Tran. Classic Mr. I didn't make this one up. This is from your exercise book. It's from your textbook. Question 5.
应该是吧？也是这样。你是用带回饭，他没有说上哪个点，有啊，点了。哪里？哦。好屌哦！好厉害哦！这有点难。 还没带你的袜子，带一下你的带。
下来，一样。对，我说你我感觉不行。哦，那可能是后面那个东西不存在。
Good. Taught you well. Fantastic. You can see it's a function algebra type. Breaking it apart, it's a double chain rule. I skipped a lot of steps here because I'm assuming your chain rule's better. Drop down the half, minus half by 1, the other side, it's 2x. And flip this, that's negative half, so it goes down here, square root of x squared plus 1, times 2x, 2's cancel out. That's the derivative of du dx, let's find the derivative inside. This is now log e of u, so it becomes derivative of log e of u is 1 u. So the chain rule says find the derivative, take the 1 u times the u dx. That's what I got here. U, same thing as square root of x squared plus 1. Multiply those two together, 2/3 will cancel out, so it's saying root 3 times root 3. Get x squared plus 1. So that's what I meant by double chain rules. There's a chain rule within your derivative. 2 chain rules there. So.
Oh.
Question 8 is the f dash equals 0. F dash is 0.
No, I think you're likely to. No, it looks like you need it. Because it tells you to find the derivative. So when they say when x equals 0, it means to find the gradient now. Because remember it said when you find the derivative, it allows you to find the gradient at one point. If they never gave you the point where it is, then you won't find the gradient, you'll just have the gradient function. But because it says find the gradient at this point, then because they tell you x equals 0, now you're changing it to an answer. So you need a value. Bio. There you go. Question 8. Down. Small notations. Chain rule.
求出来啊！求啊！不求它出来。
Ooh.
You didn't get on that weekend.
No, I was away. I was in Rye.
Oh.
Yeah, my friend was getting married, so I was just there for the weekend, chilling back with him.
那费用呢一定要写错，是有。
Maybe Friday night,
我
maybe.
边看呢，
Yeah, I'm doing a bit better with coordinating now, so I have a bit more time.
我一直没参过。我走啊。谢谢。
Friday night, I'll see you. You guys, I mean, are on Friday. If you like the. Alright, okay, cool. Wow.
Thank you.
Thank you.